Hey people, and welcome to the analytical geometry section of this paper. Okay, so we're on question 3, and question 3 says, in the diagram, AS intersects the y-axis at C, which is 0 and 6, and then B is -4 and -8, is the midpoint of AC. Okay, so this is the middle of AC. Then they say the coordinates of F are 0 and -6. Okay. And then LF is drawn parallel to AS. Okay, so remember about parallel lines, okay, and the relationship between their gradients. And then they tell us that it's drawn parallel to AS and it intersects the x-axis at G, as we can see. And then we have E is a point on LF such that AE is equal to this. So they've given us the equation of AE. Let's just make sure we remember that. That is the equation of line AE. Then lastly, they say that AE intersects the x-axis at T and SF is drawn. Okay, the first question says to calculate the coordinates of A. Okay, what did I tell you about this line AC? They said that B is the midpoint of line AC. So if B is the midpoint, this is the middle, you have one endpoint, you can find the other endpoint using the midpoint formula. Okay, so this is what we have. We have A being X and Y, and we're going to say, to find the midpoint of line AC, I'll just put the midpoint formula down first, X1 plus X2 over 2, and then Y1 plus Y2 over 2. And now we're looking at that midpoint of AC. So the midpoint of AC is B, okay, -4 and 8. So we'll say this is -4 and 8, that this point is exactly the same as this. So this is the midpoint, but here's the calculation for the midpoint when we're trying to find it. We would say the X1 plus the X2, okay, the endpoints, X values. So that's X plus 0 over 2, and then the Y values. So that's Y1 plus Y2 over 2. So that's Y plus 6 over 2. And let's find this. Okay, remember, on one hand side, you have the actual midpoint. The other hand, you have the calculation for the midpoint. So they represent the same thing. Their X values are exactly the same. Okay, so we equate them, and the Y values are. So we'll just say, therefore, this means that -4 is equal to X plus 0 is just X over 2. And then we have the Y values are equal, so 8 is equal to Y plus 6 over 2. Okay, so this is what we have. And now solve for X. You see here, to get X, there's just a 2 in the denominator. You can just multiply by 2 on both sides to get rid of it. And then we get that X is equal to -8. Okay, here, same thing, multiply by 2 to get rid of that X in the denominator. Make sure to do that on both sides. And then I'm just going to say this is Y plus 6 because the 2's would cancel. Y plus 6 is equal to, and then we have 16 over there. Then if you transpose the 6, take it over, it becomes negative. That's Y is equal to 16 minus 6, which just gives us 10. And so that means that this point A, its coordinates are -8 and the Y value is 10. And there we go. Moving on to the next question. The next question, 3.2, says, determine the equation of line LF. Okay, so it's this line LF. How do we find its equation? Well, remember how they told us that these two lines are parallel? So if lines are parallel, they have the same gradient. Okay, so if we find, we have the equation of, okay, AE, not L, not this one, AS. So we need to find the gradient of line AS first, and then it would be the exact same gradient as this line. And then do you see that LF also has a point? And conveniently, it's a y-intercept. Okay, so it's not much work we need to do here. We're just going to find the gradient. I'll use points that are already here, not the one I found. So B, -4 and 8, and then C, 0 and 6. So to find the gradient of a line, we just say y2 minus y1 over x2 minus x1. And we're looking for the gradient of line BC, okay, which you can see is parallel to the other line. It's really the gradient of AS, but I'm just going to call it BC, okay, since those are the points I'm using. So I'll say top minus bottom. So y2 minus y1, that is 6 minus the 8 over 0 minus the negative 4. And so this gives us, we'll get a negative 2 in the numerator and then a positive 4 in the denominator. And that is negative 1 over 2. Okay, so because that's the gradient of BC, that's really just the gradient of AS at the end of the day. It's negative 1 over 2. Since those points lie on the same line, and because these are parallel, we can just say that is also the gradient of line LF. So we can say the gradient of line LF is negative 1 over 2. Okay, now that we have its gradient, we can find its equation. Do you see that on LF, we have 1 point? We have the point F, and that is a y-intercept. To find the equation of a line, you simply say y equals mx plus c. C stands for your y-intercept. So since we already have a y-intercept there, we'll just put that value in there. So finally, the equation of line LF is negative 1 over 2x, and then remember that was minus 6. Okay, f was 0 and negative 6. And that is our answer. Moving on to the next question. And then question 3.3 says, calculate the coordinates of E. Okay, let's see where E is. E is this point over here. We have to find the coordinates of E. Okay, do you see that E is a point of intersection between two lines? So AE, which we have the equation of, and this line LF. Okay, so this is the point they intersect. So this is the point where their y values are the same. So we can just make those equations. We can say y is equal to y, and then we would find this point of intersection E. Okay, so the line AE, this is its equation. I'll just put that down. And then the line LF, we just found its equation. So we're just going to equate them. We'll say y is equal to y, and then you can just say negative 7 over 2x minus 18 is equal to negative 1 over 2x minus 6. I mean, I feel like I should have just put it the other way around because this one is bigger. So I want that to just become positive. It doesn't really matter. I'm just doing this. So here we are. And then I'm going to take this over. Okay, bring this over and it becomes positive. So now I have positive 7 over 2x minus, and this is still negative, 1 over 2x is equal to, and take that over, it becomes positive 6, and we have minus 18. Okay, so 7 minus 1 is 6, and 6 over 2 is 3. So this is 3x is finally equal to 6 minus 18. We have negative 12. Then divide both hand sides by 3, and x is therefore equal to negative 4. Okay, so we found the x value of the coordinate E. We need to find the y value. So if you know that its x value is negative 4, okay, then to find its y value, do you see that this point lies on both lines? Okay, it lies on AE and also lies on LF, okay? So whichever line you use is fine. You can substitute into either one of them and it will still work because they have the same y value at that point. So I'll just take the easier one, the one with the half, and I'm going to substitute this x value of negative 4 here to find its y value. So y is equal to, and we say y equals negative a half, and then negative 4 minus 6, y is equal to, that becomes positive 4 over 2, which is just 2, minus 6, which is negative 4. Okay, so our point E is simply negative 4 and negative 4. And that is our answer. Moving on to the next question. Okay, question 3.4 says, determine the equation of the circle passing through CSF if it is further given that the coordinates of S are this, okay, 24 over 5 and 18 over 5. Let me go ahead and just bring this diagram down so we can just see what's going on here. Okay, so here's our diagram. I mean, there are a bunch of things that we already have, and I should have probably put those things down. Like, I know E now is negative 4 and negative 4. We found A as well. Okay, A, that was the first question. What was that? Negative 8 and 10. So I'll just put that in. I'm not sure if it's going to help, but let's see. Okay, so this is what we have so long. And of course, we have the equation of this line. And what they want us to do is find the equation of the circle which passes through C, S, and F. So here's C, here's S, here's F. I'm going to draw a circle around there. Okay, so this is the circle. And then they say it's further given that the coordinates of S is this. Okay, so they've also given us the coordinates of S. So we know that this is 24 over 5 and 18 over 5. how does all of this help us to find the equation of this circle? Well, to find the equation of a circle, we know that the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared. So there's certain things that we need here to find the equation of the circle. We need a and b, which stands for the center of the circle. Okay, so that's the x value of the center and that's the y value of the center. And then there's r squared. So that's the radius squared, the length of the radius. So you just calculate from the center to the circumference. Can we see that here? Okay. Doesn't really seem like, it is 5 marks. So it's probably something we really need to think about. Okay. I just see something that is interesting that's going on here. Do you see this line over here? See this line, right? CF. Notice how from the origin, right? From the origin, and if you go to C, that's exactly 6 units up, right? And then from the origin, if you go down to F, that's exactly 6 units down. So I think this might be the center, but then again, I can't just assume things because it doesn't look like it's a center, but then again, the diagrams are not drawn to scale. We can test out whether this is the center or not. Here's how we can do that. And it looks like they're using Euclid here. So if this really is the center, right, then this line from one end of the circle to the other, okay, from this point on the circle to this, then that should be a diameter. If this is a diameter, then this is really the center. So how would we confirm that this line is a diameter? We can confirm that by finding out if the angle at the circumference that it subtends is equal to 90 degrees. So if this is 90 degrees, then this is a diameter. Okay, so yeah, all of maths is connected. They will use things across from different topics in maths, okay? So let's look at that. Let's see how we can actually prove that this is 90 degrees. At first I looked at it and I just thought, maybe we have to use like angle of inclination. But no, this is analytical geometry. We have coordinates already, so we don't need any of that. What we can do is find out, is this line perpendicular to this line? That's really it. Okay, just find out if those two lines are perpendicular. How do you test whether lines are perpendicular or not? You find their gradients, and then if you take the gradient of the one line and you multiply it to the gradient of the other line, if they give you -1, then the lines are perpendicular. So let's go ahead and do that. So I need the gradient of line CS. I have that. Okay, we have that. Remember we found the gradient of BC, which was really the gradient of this line. Okay, the gradient of BC is the same thing as the gradient of AS because they lie on the same line. The gradient will not change. Okay, the gradient is constant and consistent. So we're going to just go ahead and take that gradient. That gradient was line AS. Okay, there we go. Okay, BC, which is -1/2. Interesting number, okay? It probably is that case. So the gradient of line CS is -1/2. And now we need to find the gradient of line SF. So let's find that. Okay, yeah, that's why they gave us S. So we can see the gradient. To find this, I'm not going to put in the gradient formula. We already have it. So y2 minus y1, I'll start with the top minus the bottom. You can go bottom minus top. It's still fine as long as you do the same thing with the x values, okay? You can't say this minus this and then go, then this one minus, then that's just no, okay? Okay, so trying to find the gradient of line SF, and this is equal to, I'll just say 18/5 minus, that's a -6, so minus -6 all over the 24/5 minus 0. Okay, so let's see the gradient of SF, and I'm just going to use a calculator for this. And what do we have? It is 2. Okay, so yeah, this is actually following that. So you see how the diagrams are really not drawn to scale. Okay, you'd have looked at that and say, how is this at the center? Yeah, it doesn't look like it's at the center, but when you actually work out those, okay, when you find the gradient of this and gradient of that, you see that when you multiply them, they actually will give you -1. So now we're just showing them. If you take the gradient of line CS and you multiply it to the gradient of line SF, this is what we get. -1/2 times 2 is indeed -1. And so what this means is that line CS is actually perpendicular to line SF. Okay, so this really is 90 degrees. Okay, so I'm just going to tell them, because I can see that CSF is really equal to 90 degrees. This confirms that COF, that line, is a diameter. And then if line COF is a diameter, then that would mean that this is the center, because you can see that from the center to the circumference is 6 units, center to the circumference is 6 units. This is definitely the center of the circle. Okay, so that's a radius. Okay, so this is a diameter, and O is the center. O is the center of the circle. So now because of this, there's a bunch of things we know. We know the center, so we know what A and B are. And with this question, and just because the origin, okay, is at the center, and you can see that the radius is a vertical line, we also know what R is. Okay, you're going from the center to the circumference. That's exactly 6 units. That is the radius. Okay, the length of the radius is 6 units. So I'm just concluding things we know. We know O is the center of the circle. Then that means that we'll just take this equation. We know what A and B are. We'll put them in. So this means that A is just 0. If you say x minus 0, you see how you get x. So it's just going to give you x squared. And then same thing, y minus 0 is also just going to give you y, and so y squared. And so our equation currently would just be this x squared plus y squared is equal to r squared. But then we can see that the radius, okay, is from O to C. So that is exactly 6 units. So I'll just go ahead and tell them. But I can see that OC is 6 units, which is the radius of our circle. So I guess I can just say that the radius R is actually equal to OC, which is 6 units. And so finally, this means that the equation of this circle is x squared plus y squared is equal to 6 squared, which gives you 36. Okay, so that is the equation of the circle passing those points. Moving on to the next question. The last question for question 3 says, calculate the size of angle AEG. Okay, let's spot angle AEG so we can find its size. So AEG is this angle over here. How do we find that? Yeah, I can see there's 2 ways to find it really. But regardless, we actually do have these lines equations, and so we have their gradients. So you always look at the lines that create that angle. So we have AE, and then we have this line, okay, GE. Because those create that equation, here's what I can do here. I'm going to extend these lines just so that you can see the angles they form. Okay, so if you extend those lines, and I'm only doing this just to avoid finding it here, because here's the thing, okay? Do you see that these lines are parallel? And so we have alternate angles. So this angle is equal to this angle. So if you just found this one, then you found that. But another way you can do this would just be like this. So you're going to look at the point where the angle is formed, which is here. And I'm going to draw a line which is parallel to the x-axis. I know my line is skewed, but I'm just trying to, make it match this line, the x-axis. So when we have this line parallel to the x-axis, you're going to treat this line as if it is your x-axis. And then we're going to try to understand how this angle was formed. Okay, so that section over there, look at how you can form that angle. So we can form this angle over here by looking at, from the x-axis, this is the angle of inclination. So the angle of inclination of this line, okay, the blue line, so that is line LF. If you find that angle of inclination, do you see that if you subtract it by the angle of inclination of this purple line, okay, which we also have the equation of, then you're going to end up with this part. Okay, so I'm just saying this minus this would give you this part. Okay, so that's what we need to find. We need to find the angle of inclination of this line LF and then the angle of inclination of the line AE. Okay, so let's find that. So to find that, find the angle of inclination of line. Let's start with the big one. So that is this bigger angle, the blue one, and that would be LF. And what is the gradient of line LF? We already found those. gradient of line LF is negative 1 over 2. So I'm just going to say, to find the angle of inclination, we simply say tan theta is equal to our gradient. And so I know that I'm trying to find tan theta of line LF. It's equal to negative 1 over 2. And then we find this angle. So that's going to be theta of LF is equal to, and you're going to transpose tan. When you do that, we're going to be using the second function of tan. So this is going to be shift tan, and we're going to say negative 1 over 2, which gives us... Okay, so do you see that when we do this, we get a negative value, okay? So here's what it's doing. We are trying to measure the blue one, okay? So this, we're trying to measure from, and I don't know why I put this mark in here. It should start from this black line, okay? So that's what we're trying to measure because it's an angle of inclination. It goes from the x-axis to the line. We're trying to measure the obtuse angle. What it is currently measuring is this angle over here, the acute angle. So just so that it gets the obtuse angle, you're just going to say plus 180 degrees. And then there we go. That's the 153 point that. Okay, so just take that. So this gives us 153 point, and that is 4,3. Okay, I'll just leave it at 43494. Okay. So the thing is, you don't have to round off. What I can just do is leave the calculation. So I'll say this is shift tan, negative 1 over 2, and then plus 180 degrees, and I'll leave that there. And then to find the second one, we say tan, and we're trying to find theta of line AE, okay? And then we need the gradient of line AE. So AE, yeah, that's a line that they already gave us the equation of. We know that the gradient is negative 7 over 2. So again, do you see that in your diagram? This line AE, the angle you're trying to find is this angle from the x-axis all the way to the line, okay? So if it goes from the x-axis, this serves as our x-axis right now, to that line, do you see that this is an obtuse angle? Okay, it's an angle greater than 90 degrees. So naturally, it's going to give you a negative angle at first. When you say shift tan negative 7 over 2, it's negative, no problem, because it's measuring from here to here. Okay, we don't want this one, the acute angle. We want the obtuse. So then add 180 degrees. Okay, here's a way you can look at this angle. Okay, there's two ways because of vertically opposite angles, really. So with that angle, you can actually say that it's measuring this angle over here. And then you don't want it to do that. So when you are measuring normally on a Cartesian plane, remember how we measure angles? Anti-clockwise. We go this way, okay? So then 90 degrees is here. And 180 degrees, we say 180 degrees, okay? But what this did is it measured a negative angle. So you can see that as going clockwise. So this is going negative when you're measuring an angle. But then you don't want it to calculate that. You want it to find the obtuse angle. So we add 180 degrees so that it will go round. Once it reaches 0, it measures this angle, the obtuse angle, and that's what we're looking for. Okay, I hope that made sense. Okay, so I'm just going to put this down first. I know that the gradient was negative 7 over 2, but then to find the actual angle, I'll say theta of AE, that this is found by saying, we're going to say shift tan negative 7 over 2, and then we'll just say plus 180 degrees. Okay, so now just remember how we are subtracting. You're going to say the blue angle, the bigger angle, minus the purple angle. That gives you this angle they are asking for. So that's the angle AEG. So to find angle AEG, we simply say it's going to be theta of LF minus theta of AE. So the angle of inclination of AE. So this is equal to, and I'll just put them down like that. And then on the calculator, subtract. Okay, so this is what we have, and then we'll just get our answer. Okay, so finally, AEG, this angle is equal to, it is 47 point, and that 9 is going to round the 8 up to a 9. So that is going to be 49 degrees, and that is our answer. Okay, and that is it for that question. And that is the last question for question 3. And moving on to question 4. Okay, we are on the last question for the analytical geometry section, question 4, and it says, in the diagram, the equation of the circle having a center at M is, and they gave us the equation, okay? We can see everything here, the radius and the center of the circle. Diameter TMR and tangent SR are drawn. Okay, you know the relationship between a radius and a tangent at their point of contact. Maybe it would be important, we'll see. Then they tell us that the equation of line ST is this. Okay, so just keep that in mind. This line ST, we have its equation, and that's what it is. Then they say ST intersects the circle at V. Okay, and then VR is drawn. The first question, 4.1, says, write down the coordinates of M, the center of the circle. Okay, so from the way the equation is, you can already see this is in the form of x minus a all squared, and then plus y minus b all squared. So you can see a and b, which stands for the x and y values of the center of your circle, that is just 2 and 4. So we can just tell them we know that M, the center, is simply 2 and 4, and that's our answer. Moving on to the next question. The next question, 4.2, says, show that the coordinates of T are negative 2 and 1. So find the coordinates of T. So we just found M, and M is negative, 2 and 4. Okay, we have that already. And now we need to find T. Okay, if we had R, then we could have found it like that, but we don't. So what else do we have? Remember they gave us the line ST, okay, and the equation of line ST, which is this line. And can you see that T is the point of intersection of this line and your circle? Well, there's 2 points really. There's T and V. So we can take the equation of the circle and take the equation of that line and then find where they intersect. Okay, so we can do that by using simultaneous equations. You can just take both equations, because really in the question 1 sections, okay, sometimes you see questions like this. So we know that ST, right, the equation of the line is y is equal to 2x plus 5. And you already have the equation of the circle. I know that the one that you'll probably be used to is the one where they will say something like x squared plus y squared is equal to something. Okay, and then it will ask you to solve for x and y in this equation. What you are actually doing is, when you're solving for a simultaneous equation, you're taking 2 lines or graphs, okay, and you're just trying to find the points of intersection between these two. So that's what we're doing here. But the equation of our circle is this, which I'll just put down here, okay, and then we have this. Okay, so we're just trying to solve for x and y in this. Here, y is already a subject, so I'll just go ahead and call this equation number 1 and then equation number 2. So we're going to substitute equation number 1 into equation number 2. Let's go. So we'll just say, wherever you see y, replace it with 2x plus 5. So I just have x minus 2 all squared and leave that, plus, and then I see y. So I'm going to replace this with 2x plus 5. Then minus 4, and then all squared is equal to 25. And all you're doing is solving for x in this equation. So we have x minus 2 all squared plus, and this is 2x, and that's just going to give you a plus 1 all squared equals 25. Okay, there's no other way to simplify them. So we can simply just go ahead and start squaring. So take this and square it. And I'm not going to use this method where we multiply twice, okay, because long methods can lead to mistakes. So I'm going to take the short method where I take the first term and I square it, and it gives you x squared. Take the last term and square it, and that gives positive 4. Then the first term times the second term, you see that gives you negative 2x. You're just going to times this by 2. So that gives you negative 4x. Okay, then the next part. First term, square it, that gives you positive 4x squared. Last term, square it, positive 1. And then first term times second term, that is 2x. Then times 2 is positive 4x. Okay, so this is what we have there, is equal to 25. We might as well bring that over. So minus 25 is equal to 0. Okay, so you see it's going to be a quadratic because you're going to have 2 solutions, 2 x values. This one here and that one there. That's where this red line intersects the circle, where it cuts through the circle at those 2 points. So we have x squared and x squared go together. That's 5x squared. And then the negative 4 and the positive 4, yeah, those are gone. Okay, so negative and the positive of the same thing, they would just become 0. And then we have 4 plus 1, which gives us 5, and then minus 25. What is 5 minus 25? That is negative 20 is equal to 0. Now, do you see that between 5 and 20, we have a common factor of 5? Okay, so we can divide both hand sides of the equation by 5, and then we get, so this is x squared, 20 divided by 5 is 4, so minus 4 equals 0. And we have a quadratic equation, and you can use difference of two squares to solve for this. So to factorize it first. So factorize, and then we're going to set it equal to 0. So this is going to be x and x to get x squared, and then 2 and 2 to get 4. And you just say plus and minus. So our solutions are x is either equal to negative 2 or x is equal to positive 2. So those are our answers, and let's see which one belongs to T. So T is a point that, do you see that this point is in the second quadrant? Okay, the second quadrant is where our x value is negative. So you have to take the negative one. Okay, so I'm not taking the positive, it's not applicable for this. And so I'm going to take this. So I'll say T is in the second quadrant, therefore x is equal to negative 2. Okay, so the x value of T is negative 2. And then I'm going to take this, and I need to find its y value because they want the full coordinates of T. Okay, so to find the y value, you see that you already have the equation of ST. Since this lies on this graph, I'm just going to substitute its x value of negative 2 to get its y value. Okay, so there's our equation, y equals 2x plus 5, which you already had. Okay, here. So we'll just take this and substitute that x value and get your answer. So finally, y equals, and we're going to just say 2 times negative 2 plus 5, and y is equal to, that's going to be negative 4 plus 5, which is 1. Okay, so T is simply negative 2 and 1. And you can just check that is correct. Okay, so that is our answer there. Moving on to the next question. Then question 4.3 says, write down the coordinates of V. Okay, so where is V? V is, okay, so that's the second point. You see that that line had 2 points of intersection, the T and the V. So V is the other one. So this one was negative 2 and 1. So we'll just put that down there. This is negative 2 and 1. And then this one was the one with an x value of 2. So we just need to find its y value. So its y value, you can use the same line since it lies on this line ST. I'll use the equation of that line. So that was y equals 2x plus 5. So that is 2. And its x value is 2. Then plus 5. And so that's 4 plus 5, which is 9. Okay, so V, the coordinates of T, are 2 and 9. And I'm just going to fill that in our diagram. That's 2 and 9. So we have it. Okay, so that is it for that question. Moving on to the next question. The next question says, calculate the gradient of line TR. So TR, that is our diameter. Okay, so T to R. So to find the gradient of this line, you already have T and M. Okay, so that is the gradient of TR. The gradient is the same all through since all these points lie on the same line. So I'll take point T and M and we'll find the gradient. Okay, I'll just start by telling them the gradient of TR is the same thing as the gradient of TM. And then we can just find that. Okay, so to find the gradient of a line, you just say y2 minus y1, okay? But I'm just going to straight away go. So TM, gradient of TM is, and I'll say bottom minus top. So y2 is 4 minus 1, and then again, bottom minus top, that's going to be the 2 minus the negative 2. So 4 minus 1, that's 3, and then that gives you, that would become a plus, okay? Negative times negative is positive, so that's 2 plus 2, which is 4. Okay, so the gradients, and I keep saying TM, TR, okay, I already said it's equal to this. So TR is 3 over 4, and that is our answer. Moving on to the next question. Then question 4.5 says, determine the equation of SR, the tangent to the circle at R. So there's this tangent to this circle, SR, and we need to determine the equation of this tangent. Okay, we actually have everything we need. We have the gradient of TR. Remember the relationship between a tangent and the radius at the point of contact. So if this is our radius MR, okay, it means that this is perpendicular to this. So you can really just say TR is perpendicular to SR. That's fine. And because of the properties of perpendicular lines, you know that the gradient of this line SR, okay, multiplied by the gradient of the line RT or TR, that is going to give you -1. Okay, so you see how you can find the gradient of line SR and then we can find its equation. Okay, but before finding that gradient, do you see that there's a point that we need? Okay, to find the equation of a line, you need its gradient, but then you also need one point on the line so that you can find its y-intercept. Okay, so with this, we don't have a point on SR. Okay, R is missing, so we still need to find that. But we have enough info to find this. You see that this is a diameter, so this is the midpoint, and so this is the one point, and this is the other point at the end of the diameter. So we can use the midpoint formula to find R. Okay, so this is following the same thing we did in question 3. And let's go. Okay, I'll just bring this down. Okay, so finding R, we'll just call it X and Y so long. And so we are saying to find the midpoint of this line, TR, that we find it like this. We say X, okay, plus the X value here, so X1 plus X2. I'll just put down the formula. And so the midpoint of TR, we already have that. It's this M, okay, which is 2 and 4. And then to find the midpoint, to actually calculate it, we'll say this is X1, this is X2, Y1, and this is Y2. Okay, so this is X plus -2, which is just X minus 2 over 2. And then we have Y plus 1 over 2. Okay, so these two are equal because this is just the calculation for the midpoint of TR, and this is the actual midpoint of TR. So we're just going to say 2 is equal to, or let's just start here, X minus 2 over 2, that X value is equal to this X value of 2. And then this Y plus 1 over 2, that Y value is equal to this Y value of 4. And then solve for X and Y. So I'll multiply both hand sides here by 2, just to get rid of that 2 in the denominator. And then we have X minus 2 is equal to, and that becomes 4. Therefore, X is equal to 4, and then that comes over to become positive 2, and we have 6 there. Then we have here times both hand sides again by 2. Or you can see this as cross multiplying. Okay, you're saying 2 times the 4 is 8. And then the Y plus 1 times 1 stays the same, so Y plus 1 is equal to 8. And so Y is equal to 8 and then minus 1, which is 7. Okay, so that's what we have. And I can finally say that this means that R is simply 6 and 7. Okay, those are the coordinates of R. Now that we have R, we can go ahead and find the gradient so we can find the equation of this line. Okay, so R is 6 and 7. So the gradient of this line, remember you find the gradient of the diameter, or okay, which we already have. We have the gradient of the diameter, and you're going to use that to find the gradient of the tangent, because the tangent and the diameter are perpendicular. So the gradient of TR, we already had that. That was 3 over 4. So this is 3 over 4. And so to find the gradient of SR, you know that if you multiply them, they will give you -1. And so here's the quick way of doing this. You can't deal with it that way and then still say they gave you -1 and say, okay, this is 3 over 4. This is gradient of SR is equal to -1, and say, okay, we are multiplying by 3 over 4. So why don't you just divide both hand sides by 3 over 4, and then you'd get your answer. Another way to do this is to simply just say, because you know that these lines are perpendicular, I'm going to go ahead and state that first. I'll tell them that TR is perpendicular to SR, and so therefore, this means that the gradient of line SR, you would find this by simply swapping the numerator and denominator here, and then you multiply that by -1. So it gives you -4 over 3. And so that is our gradient. Okay, so we have the gradient, we have one point. On the line SR, we can find its equation. So we'll just say you can use y equals mx plus c. I'm going to use this one, y minus y1 equals the gradient and then times x minus x1, and we just substitute. So our x1 and our y1 is our point on the line. So here, that's x1, that's y1, and there's our gradient. So we'll say y minus 7 equals negative 4 over 3, and then x minus, and we have 6. Okay. And then we have y is equal to, so I'm going to take that over, but let's just FOIL out here first. So that's going to give us negative 4 over 3, and then we'll say negative times a negative, which is positive. If you say 4 over 3 times 6, do you see that across, okay, you have 3 in common. Divided by 3 is 1 here, divided by 3 is 2, so you're just saying 2 times 4, which is 8. Okay, so that gives you a positive 8. So this is negative 4 over 3x plus 8, and then take the negative 7 over to become a plus 7. And then y is here. So y is finally equal to, and you have negative 4 over 3x, and then that gives you, that's just going to be 15. Okay, so plus 15. And that is the equation of this line SR. Moving on to the next question. Okay, question 4.6 says, another circle, another circle passes A, which is negative 3 and negative 1. These aren't points we have here, right? Okay, yeah, we don't have any A or stuff. So there's a new circle, and it's going to pass through A, and then B, which is a point we don't have, and then C, such that AC is a diameter of the circle. Okay, let me just start drawing this out. So we have another circle, and then it's going to pass A, which is a point, and that point is negative 3 and negative 1. So let's just say we went like that, and negative 1, okay? So down there. So it passes through that. Let's just say that's A, negative 3 and negative 1. And then B, which is a point that we can't see. And then C, which is 2 and 3. Okay, so 2 and 3, maybe that's up there. So let's just say B is here. Okay, this is X and Y. And then this is C, which is 2 and 3. So what they tell us is such that AC is a diameter. Okay, let me just draw this, just so that it's believable that that is a diameter. Okay, so here we are. Now, I'm not assuming that the center is at the origin. I'm just drawing it like this just to make sense of this. So this is a new circle. And then they tell us that the circle passes through A, B, and C and intersects the given circle with the equation this. So the given circle, the one that we already have, it intersects this one. And I mean, we can just double check. You can just see this is a negative 5. That's a constant. So if you had to take your circle, the equation of the circle we had, and you distribute out, okay? If you distributed these ones out and you put the constants together, if you end up with that negative 5 as well, then yes, it is. But yes, for now, I'm just going to go ahead and accept that. They say intersects the given circle, okay? So with this info, they want us to determine the equation of the line that passes through the points of intersection of both circles. Now, I know that this question, because you see 6 marks and, it's at the end, it would seem like, oh no, this is one of those difficult ones. It's actually a very simple question. And what they're asking you is, they're just saying, we now have these 2 circles, okay? The circle we originally had, which was this circle over here, okay? Say this is that circle, and this other circle. So they intersect at a point, right? At 2 points, because it's a circle. So as long as they're not touching like this, they don't intersect at 1 point, they intersect at 2 points. And all they want you to do is find the equation of the line on which they intersect. So, for example, let's say they intersect here, right? And here. Then the equation of that line would just be like that. And that would be it. Something that I will just note is that it still kind of ties back to a question that we had previously. We were able to find these points of intersection, right? Simply because they were on a line, okay? And they were really just the points of intersection between the circle and these lines. Do you see how you were able to find the points of intersection even if you were given the equation of a circle and the equation of a line? In the same way, you're also able to find the points of intersection, but I'm not looking for the points of intersection in this case, but you can actually find the points of intersection if 2 circles intersect. Again, this is going to be a case of simultaneous equations. So what we're going to need is, we're going to need the equation of circle A. Okay, this circle, take that circle, and then we need the equation of this circle, and we are going to work with them as if we're working with a simultaneous equation. So we'll take this as equation 1 and then equation 2, and you can simply say equation 2 minus equation 1, and then that would give you your answer. So the idea is, you see, because these are circles, it's difficult to now make x a subject or y a subject. So this is a way that we can do this, okay? So to find the equation of that line, we are simply going to find the equation of these circles. So the circle that we have here, okay, with the diameter AC, that is the only one we don't know. We don't actually know what the equation of that circle is. But we do, however, know the equation of the given circle. And they've helped us to just, distribute. We don't have to distribute there anymore. They already did it for us. So we'll just say the equation of the given circle, the one that we already have, the one centered at M, that one is all of this, okay? That's the x squared minus the 4x plus y squared minus 8y minus 5 is equal to 0. We have that one. Now we have to find the equation of this one, okay? Number 1. So what have we been given? We've been given 2 points, but those 2 points are the endpoints of a diameter. So yeah, it's perfect. We can actually use that. So to find the equation of a circle, remember the formula x minus a all squared plus y minus b all squared is equal to r squared. You just need the center of the circle and the radius. So to find the center of this circle, we're simply just going to use those endpoints, and we're going to find the midpoint. Okay, so find out where the midpoint is. Remember, I am not saying that they intersect at the origin. Okay, this was just a rough sketch. I don't really know where they intersect because, I'm not trying to, well, we'll see. Okay, so let's just find out what exactly that is. So to find this center of the circle, you need to find the midpoint of this line AC, since this is the diameter and then this is the center, this is the middle. So we just need that midpoint. Okay, so I won't put the formula down, we already used it. So x1 plus x2, okay, over 2, and then -1 plus 3 over 2. Those are the y values. And let's find that point. So that's just going to be 2 minus 3, which is -1 over 2, which is, okay, it's -1/2 that we have there. And then 3 minus 1, that's 2. 2 over 2 is 1. So this is the center of this circle. As you can see, it's not at the origin. Okay, so the center of that circle is -1/2 and 1. And then we need to find r squared. To find r squared, it's not really a problem. You already have the center, so we can just do this. We can say x minus and then fill in your a and your b value. So this is x minus, and we have -1/2, and then all squared, plus y minus, and then we have 1. All squared is equal to r squared. Then just simplify this. So this is now x, and this becomes plus 1/2 all squared, plus y minus 1 all squared is equal to r squared. And to find r squared, you just have to fill in x and y. We have 2 points right now on the circumference of the circle. So choose any one. I'll just take the positive one because it's easier to use, 2 and 3. So taking C, which is 2 and 3, and I'll substitute it. So we have 2 plus 1/2 all squared plus 3 minus 1 all squared equals r squared. And then I'll get this. Okay, so this is what we get. I'm going to leave that as 41/4. That is r squared. And so it means that the equation of this circle that they gave us, this new circle, is x plus 1/2 all squared plus y minus 1 all squared is equal to 41/4. Okay, yeah, I can see why it's 6 marks. Then we are going to find the equation of this circle, okay, distributed, so that it can also be in this same format, because that way we can work with them together. We can say equation 1 minus equation 2, or equation 2 minus equation 1. It's still fine. Okay, so let's distribute. This is going to be x all squared gives you x squared. Then 1/2 all squared gives you 1/4. Then you say x multiplied by 1/2, which is really just x over 2, or if you want 1/2x. And then you multiply this by 2, which is 2/2x, which is just x in the middle. Okay, you can't distribute the way where you just write it twice. That's also fine. So plus 1/4. And then we have here y all squared would be positive y squared. Negative 1 all squared is positive 1. Then the y times the negative 1 is negative y. Times 2 is negative 2y. Then I'm going to bring this over. So it's minus 41 over 4 is equal to 0. And finally, x squared plus x, and then plus y squared minus 2y. And then I'll take this 1 over 4 plus 1, and then of course minus that. I'll just quickly find out what that gives us. Well, really 1 over 4 minus 41 over 4 is negative 40 over 4. Then you're just saying plus 1. So 40 divided by 4 is already 10. So this is negative 10 plus 1, which is negative 9. Okay, so we have just minus 9 is equal to 0. And there we go. Okay, so this is what we have here. And I'll go ahead and call this my equation number 1. And then the equation of this one, okay, which we already had, I'll call that equation number 2. Okay, so this is equation number 2. And now to find that line, okay, to find the equation of the line where these two intersect, we're simply going to say equation number 2 minus equation number 1, or 1 minus 2 is still fine. So I'm going to take it as if it's just a normal sum that we're taking, like x squared, because I don't want it to get complicated. There's a lot of things that we're working with here. I can simply just say x squared minus 4x plus y squared minus 8y minus 5, and say we are subtracting by this. Okay, so this is x squared plus x plus y squared minus 2y minus 9, and then of course is equal to 0, but it's just this part we're working with. So it's really just that left-hand side minus the left-hand side, right-hand side minus the right-hand side. Okay, so here is equal to 0 is equal to 0. So when we're subtracting this, you're going to take the x squared and you're saying minus an x squared, which just gives you 0, okay? So these would just cancel. And then it's the negative 4x minus an x. So negative 4x minus x is negative 5x. So this is what we have here, negative 5x. And then it's the positive y squared minus y squared, which gives you 0. So those cancel. Then negative 8y minus negative 2. So we're saying negative 8y minus negative 2. You see how those, okay, they would become a plus. So negative times negative is positive. So you're just saying negative 8y plus 2y, which is negative 6y. And then we have negative 5 minus negative 9, which of course is going to be negative 5 plus 9 because of the minus minus. And so 9 minus 5 is 4. So it's just positive 4. And then 0 minus 0 is 0. Okay, so there. Left-hand side minus left-hand side, right-hand side minus right-hand side. And so this is what we have. This is actually the equation of the line. You can't stop at this point. Or you can write it in the form of y equals mx plus c. That's also fine. So you just make y the subject here. So negative 6y is equal to, and I'll take everything over. So that's positive 5x minus 4. Okay. And then you must divide both hand sides of the equation by negative 6. So finally, I'll just say the equation of that line is y equals negative 5 over 6. And then what is negative 4 over negative 6? It will become positive. But then 4 and 6 have 2 in common. So divided by 2 is 2. Divided by 2 is 3. So that's plus 2 over 3. Yeah, I noticed I forgot the x. X. Okay. So negative 5 over 6x plus 2 over 3. And that is our answer. And then moving on to the next question. Okay, question 7.4 says, if a constant k is added to the equation of the circle such that this, okay, plus k is equal to 25, so there they've added the constant k, what effect will k have on the circle if k is greater than 0 but less than 25? Okay, so it's just a 1 mark question. It's actually something that we can just explain. You see, with the equation, right, they add k to it. If you add a number, constant, to the equation of a circle, what happens is, say that constant was, let's just take a number within this range. So let's just say that number was 5, okay? So you'd have y minus 4 all squared. Then you say plus 5 is equal to 25. Now what will you do with this 5? Well, to simplify this so that it's back in the standard form of the equation of a circle, you would take the 5 over. So it's going to be x minus 2 all squared plus y minus 4 all squared. And then when that comes over, it becomes negative. So it's 25 minus 5, which gives you 20. Do you see what changed between this and this? Okay, this would be the radius, r squared, changed. So the size of the radius is going to change. And so you would have a circle that used to have 25, okay, as r squared, or 5 as your radius. But now that radius is going to decrease. So you're going to have a situation like that. So the square root of 20, that is 2 square root 5. Okay, so we know it's going to decrease. But remember, they do say what effect will that have on the circle if k is between 0 to 25, okay? So from 0 to 25, we tried a number like 5, okay? Now imagine you start increasing this number. So 10, for example. Do you see that it will make this even smaller because this goes over to become negative and then the radius becomes even smaller. So your radius is going to range from certain values. It used to be 25, but the bigger this number gets, the smaller the radius becomes. So because we're looking at numbers where k is greater than 0, so look at the numbers you're looking for. So between 0 and 25, numbers greater than 0 but less than 25. So let me use an actual radius. Okay, I just put a line here and then just see what happens. We know that we are only using positive numbers, so when they go over, they become negative and they decrease that radius. Okay, say k was equal to 1, then you just have a 1 here. It goes over and then it decreases that by 1, making this 24. If it was 2, it makes it 23, okay, and so on. So it can go from a length of less than 25. Okay, so we tried this out and you see that if you try where k is equal to 1, it gives you 24. It will go from, the radius would be a radius that is less than 25, because it can be things like 24, 23. And you see that the highest value of k that we can add to this would be a value less than 25. Say that value was 24. What would happen? You take 24 over, it becomes 25 minus 24, which gives you 1. So it means that that radius, the radius of the circle, is now going to range between numbers that are greater than 0 but less than 25. Okay, because it's never going to be 0 because they never said k can be equal to 25. If k could be equal to 25, then when you take this over, it's going to be 0. Okay, so it's going to shrink this radius so that its length is greater than 0 but then less than 25. Okay, you can test it out on your own. So this is if the radius was equal to 1, the radius was equal to 2, the radius was equal to 3. Okay, so we're looking at those and it's values that are greater than 0 but less than 25. That's what's going to do to that. Okay, so they were nice to at least give us this kind of thing and they didn't change that number. So I'm finally just going to say that this would shrink the length of the radius, okay, to lengths that are between 0 and 25. So greater than 0 but less than 25. Okay, and yeah, that is my answer for that. The length of the radius will be between 0 and 25. And that is it for this question. And that is the last question for the analytical geometry section of this paper. And I will see you guys in trigonometry.